The demand for fuel cells and electrolyzers is growing in lockstep with the call for new, cleaner energy. Electrolyzers produce hydrogen gas by splitting water molecules into hydrogen and oxygen through a process called electrolysis. This takes place in a basic electrolyzer stack, consisting of a positive and negative electrode separated by a membrane. An electric current is applied to the electrodes, creating the hydrogen. Fuel cells use a reverse electrolysis process and consume hydrogen as the fuel source and oxygen as an oxidant, producing electricity and water. There are different types of fuel cells and electrolyzers. Common fuel cells in production are Proton Exchange Membrane Fuel Cells, Solid Oxide Fuel Cells, and Phosphoric Acid Fuel Cells, while typical electrolyzers are Proton Exchange Membrane Electrolyzers, Solid Oxide Electrolyzers, and Alkaline Electrolyzers. Electrolyzers and hydrogen fuel cells are complex and, depending on the electrochemical makeup, require different alloys and materials, one of which is woven wire mesh, also known as wire cloth. You can use wire mesh in various functions within the subcomponents of a fuel cell or electrolyzer, including the Gas Diffusion Layer, Porous Transport Layer, Gas Diffusion Electrode, Membrane Electrode Assembly, MEA stack, cell stack, and others. Within these subcomponents, woven wire mesh and other types of media are used in the electrochemical stack to perform one or more of the following functions: current collector, gas dispersant, electrode enhancer, catalyst anchor, and electrolyte substrate or slurry anchor. So, why should you consider wire mesh over other media to perform these functions? First, wire mesh has interchangeable parameters. Let's talk about the porosity of wire mesh and the surface area of wire mesh. Porosity impacts the control over the flow of gas through the wire mesh electrode structure. Many designs require a specific level of porosity. The amount of material available for the electrochemical reaction is affected by the surface area, which directly impacts reaction rates and efficiency. The surface area of wire mesh increases with the number of wires in each direction per square inch, which is also called the mesh count. With wire mesh, these parameters act independently of each other. This means you can achieve the same porosity with varying surface areas, depending on your needs and cost requirements. The same can't be said of other media, like expanded metal, where changing one parameter directly impacts the other. Additionally, wire mesh offers greater flexibility. The unique peaks of wire mesh mean they penetrate deeper into the application, offering a greater surface area to maximize the contact with active materials. The woven topography also means wire mesh is very flexible and is able to fit into the design of the cell stack, maintaining its shape and contact between the individual wires. Finally, the multiple contact points allow for the increased conductivity of wire mesh. Even when the wire mesh is flexed, it still provides consistent and repeatable performance over a long time. Compared to other media, wire mesh is less likely to deform or break under the high pressure or temperature conditions present in some fuel cells and electrolyzers. This makes it much more mechanically stable and durable. To achieve even greater conductivity, additional processes can be applied, like cold bonding wire mesh. Cold bond is a process pioneered by the engineers at Gerard Daniel over 20 years ago. The process enhances contact between surfaces, as well as controlling the depth of wire mesh. It stabilizes the pore structure and edges by mechanically locking the weave together. The sample on the left is untreated. The sample on the right has gone through the cold bond process. The process achieves some metallic bonding between interfacing surfaces, so all parts of the mesh maintain full electrical continuity. Woven wire mesh for hydrogen fuel cells and electrolyzers provides excellent value as a very controllable and repeatable product. However, other media may be a better fit based on the design of your cell. Expanded metal, carbon cloth and paper, and sintered random fiber and felt are other options commonly used. No matter what your requirements are, partner with a trusted supplier that can help you source the right material to meet your specifications and timeline. Gerard Daniel has been a leading provider of wire mesh and other media for 70 years, with 20 years of experience working in the electrochemical battery, fuel cell, and most recently electrolyzer market segments. If you would like to receive a complimentary wire mesh sample book, along with more technical details on wire specifications, alloys, and plating processes, activate the QR code on the screen or contact one of our wire mesh experts directly through our website.